Hello and welcome back to Get Kafka-Nated. We explore the fascinating world of Apache Kafka, from architectural deep dives to the people who make it all happen. I'm Hugh, your host, and I'm excited to be back with you today for another episode. Today, we're diving into something that affects everyone working with Kafka, but doesn't always get enough attention: realistic test data generation. I'm delighted to welcome Michael Drogalis, founder of Shadow Traffic and former principal product manager for stream processing at Confluent, where he led development of Kafka streams and KSQL. Welcome to the show, Michael.
Hey, thanks for having me, Hugh. It's good to see you.
Great to have you here. So I think we were saying in the pre-show, but you've had an interesting journey. Like, you've gone from founding distributed masonry and building stream native data warehouses to leading the stream processing products at Confluent to now building Shadow Traffic as a solo founder. What drove you after these years in working in different areas of the streaming domain to focus specifically on this synthetic data generation problem?
Yeah, I think, I don't know, it's been a good career arc. I just really like building things. And so I've just sort of gravitated from one problem to the next. When I left school, stream processing was this really new, interesting thing. And I didn't really know enough to realize that it's actually a really hard domain. And so I just started working on it because I was young. I didn't really have anything better to do. And, the gravity of it just sort of showed me this. It's a very interesting space to be. And then stream processing kind of led to recognizing the problem of, Kafka needing some kind of tiered storage. And then my company ended up getting acquired by Confluent, and there was lots to work on with streaming. And then I just wanted to keep building. And the next logical problem that I saw that was at least a candidate was having enough test data for all kinds of use cases. And so there's no plan about it. I just kind of found the next most interesting thing and tried to solve it.
Just finding that next niche, that next big problem to solve. It's a pretty cool way of thinking about it. Talking about your early career, so you worked on the Onyx platform early on in that. I feel that you're being very modest about how you got into streaming maybe, but how does the experience of building an open source streaming system from scratch kind of influence your work now, and how did that influence those years following, kind of with distributed masonry and Confluent?
Yeah, all the tech aside, it was actually a really good experience doing that as sort of a young person in the field, just learning to work with other people, just figuring out how to be a professional. And then that was kind of like the heyday for open source, I think, when things were going really well. And so I got to meet a lot of people. I got to understand how bigger projects worked. I got to go from kind of small project and then feel the growing pains of adding more contributors. And so just as sort of a social experience, it was really good. And I don't know if I was a younger engineer listening to this today, even though open source is maybe a little less fashionable now, I'd probably still do it just to sort of build a network and have a great, set of projects to show off. But it sort of just, it helped me definitely get a footing in the ecosystem. It definitely helped me build all my connections to the folks who continue to play a really prominent role in streaming today. And so it was a great place to start. And like I said, I think it was sort of fortunate to start working on the processing side because that got less attention until maybe more recently. And so I had more of a niche to go carve out and kind of figure out what was going on. And I think that can be a good thing when you're just trying to do your own thing and figure stuff out.
It's interesting, definitely. It's something that I've heard from a lot of the guests on this show when it comes to talking about the role that open source has had in their career, is that idea of community and network being such a huge part of the ethos of building projects like this together.
Yeah, absolutely. Absolutely.
So coming back to that, talking about finding your niche in processing and in generating test data now at Shadow Traffic, why is generating realistic test data for Kafka so hard? What makes streaming data different from just mocking or generating static data sets?
Yeah, I had been working in this space long enough where I was sort of looking well, what's the recurring set of problems that bugs me? And certainly having enough test data for either, it comes up with engineering, having the right kind of data flows to be able to do smoke tests or just building demos. There's just all sorts of use cases for synthetic data. I had basically observed that there's kind of two hard problems to doing this really well. One is sort of mastering the realism of the data. So you may have an application that processes geospatial data, and so you need addresses that reside in Texas. And so that's a whole side quest to go figure out. That's something new, but it is certainly something that plagues a lot of people. But the other that is way more complicated is data orchestration, which is you need the right data to show up at the right time. And this is why it's hard in streaming, because if you're testing a batch system, you really just kind of need to take a static set of data and then plonk it down And if you have the data once, it's sort of like you're frozen in time. But when it comes to streaming, the cadence with which the data matters that kind of makes the entire application. And you see this with all kinds of things. So when I talk about data orchestration, you could have data that is relationally linked. And so like imagine like a customer stream and an order stream, the data inside of those matters. And then also the order with which they arrive matters. And there's all kinds of sub problems that are like that. And my current job and product right now is discovering more and more of those. And it's fun. It feels like they're inexhaustible, though there is a long tail where the majority of them matter. And then, you just go kind of find more and more of them to build a more complete product.
On the sort of talking about kind of how hard of a problem this can be, I think you've mentioned before this idea of like a $10,000 demo problem. Can you walk us through a little bit about kind of what you mean by that and the costs that engineering teams face when having to build out some of this sort of synthetic Kafka workload?
Yeah, I'm a really big fan of naming problems that I solve. It's something I've kind of figured out more recently. It just helps people focus on like, well, what is the end goal that I'm doing? And $10,000 demo problem was a nice sort of tagline to say, well, I'm helping people eliminate the side quest of finding data to do anything that could be a demo, that could be a test. And yeah, my observation was that like I had been part of many keynote demos. I had been part of many, the construction of many integration tests. And every single time it was sort of like, okay, here is the main goal that we want to solve. We want to go demonstrate this feature. We want to show off this functionality or whatever. And then like step one was, oh, we have to get some data to do it. And it was always this like extra thing that sounded like it was going to take a day. And then it ended up taking a week. And especially in the case where like, you're doing something that rolls up to management in your company, you never want to like tell people that it took you like 4 days to just go get the data. So you work on it at nights. And I don't know if it's $10,000, but like it is certainly way more expensive than people think when you just add up the hours that you're like, well, I spent time Googling for data sets. That didn't work. I wrote a little script. I realized that was too simplistic for what I wanted to do. I wrote this complicated thing and then there were bugs. And that's just been my experience every single time. And obviously people end up solving it, but I just think that they invest way more energy in it than they have to. And there's the evidence is that there's lots of tools out there that do mock data. Some are simpler than others. Some are more complicated. I think I found a sweet spot for it. But yeah, it's just one of those deceptive problems. Every time I tell people about the product, they're like, I instantly know what that is. And that's a good feeling.
It's definitely something that I remember running into, like coming up as a junior doing stuff with Kafka, working for a retailer in the UK and having like this whole parallel Kafka infrastructure that we were maintaining so we could keep old events in Kafka so we could run them back through for testing and anonymize them. And like that became basically my entire job for a while, was just maintaining the infrastructure necessary to do testing. So yeah, definitely the one where I'm like, I remember hearing the $10,000 demo problem for the first time, and I'm like, yep, that. I know I was part of that.
I'm missing a zero if it was somebody's full-time job, at least. But yeah, totally.
So, talking about shadow traffic, and this is a product that you've built, from greenfield, so you've had a lot of flexibility, I imagine, to think about like how you want this product to work and the developer experience around it. You're using a declarative JSON DSL, as I understand it, right, to get people to design their synthetic data, that sort of template it, rather than maybe like writing it with code or doing an SDK or something like that. What were the technical trade-offs you considered when you first started designing shadow traffic, and why declarative rather than imperative?
Yeah, I think there's basically at least two sources of complexity when you're creating like hard synthetic data. And when I say hard, I mean, like, again, not just coming up with like better email addresses, but orchestrating the sequence with which your data arrives. And one is definitely like the developer tooling. When you think about what I do, I have, as you said, a JSON DSL. You just describe the shape and the semantics of your data with data. It's that DHH quote from Rails. Like, think about all the things you're not doing. You're not picking a programming language. You're not getting a build tool. You're not setting up the JVM. There's just an infinite number of things that you don't have to do because you're just describing the structure of your data with more data. And then the other is because you're doing it with data, you have this like mirror into what you want to create. And so the deeper your data goes, you don't have to create this like nested imperative thing that everybody's done 1,000 times and is really ugly. But you just have this JSON structure where the kind of the theme is really simple. You just take a snippet of the data you want to generate, and then you rip out the concrete values and you put in these little JSON maps that say, here's what I want to randomize. And the library is rich enough that you can create these sophisticated composite data structures. And so I guess the technical trade-off is that like you have to rely on me, the core maintainer, to provide enough expressivity. And so that is a real trade-off, but it's something I've been able to sort of stay ahead of the curve. And I think the trade-offs are pretty good.
How do you handle, like, as the maintainer of this DSL, how do you handle the balance between that expressiveness and the simplicity? Like, I imagine you have some customers who are real power users coming to you being like, oh, we want these like huge features. How do you like build a solution that works for all of your customers?
I have a very simple product management strategy. Like I did product management at Confluent like properly for 5 years. I ran a company before. Everything in my experience says like go find people who have real problems, figure out what they're really trying to solve, and then do it for them. And if you are consistent enough with the problem that you express and you say you want to solve, and you really understand the person that you're talking to, you will be able to pick through and find some consistency in the solution for them. And you will find people who have more simplistic problems, and you'll find people who have more complex problems. But as long as you are disciplined enough not to sort of like bite off more than you can chew, you can build a beautiful product by just going and being attentive to people and being very invested in what they're trying to do. And it tends to not be the case where you need to just build these incredibly large features. You just need to add the next logical thing. And for me, that was building like first scalar functions. Let's create some good strings and integers and booleans or whatever that like was easy to use. And then it was more composite data structures. And then I ended up adding geospatial data and then primitives to do like sequentially tracked data. And on their own, none of them are like mind blowing, but in a sequence, when you put them together in the right way, they end up adding to something more. And so it's a very simple-minded product strategy, but it's one that I think works really well.
I think you do a very good job there of making something that is very hard sound very simple, of looking at all of these disparate requirements and like pulling it together and being like, oh, like these are the building blocks, these are the core that people can use to achieve what they want to achieve. And I think definitely I've seen with shadow traffic, you do that very well.
I've built an amazing number of products that have failed or have never been used. And I think if you do this long enough, you start to develop this spider sense for like, okay, someone says they want this feature, and then you realize they actually don't, or that's not the problem they really want to solve, or it's just not going to be congruent with what you actually want to do. And so you should take a pass on it. So it's built on a mountain of failures, to be honest.
I feel like a very common thread across engineering as a whole. People are like, oh, how are you doing all this complicated stuff? And you're like, you should have seen me 5-10 years ago. Following that line on your experience as a product leader, you worked very extensively on Kafka streams and KSQLDB at Confluent. How did that experience of building these huge stream processing systems influence how you think about data generation, and what patterns from stream processing have you brought with you to shadow traffic?
Yeah, I mean, that whole experience at Confluent was definitely the bedrock where I most acutely felt like this lack of test data made it very hard to do my job, because we would do things like implement auto-scaling with KSQL, and the engineering team would come back very proud, and they're like, yes, we've done it. We've done this hard thing. It took us like a month or more. And I'd be like, great, I want to try it. And they're like, well, go find some test data. I was like, well, I don't have any. And so it was almost like we missed the punchline, or at least I personally felt like I never got to like really exercise the system. And I just thought that was such a common pattern that I saw everywhere, where there were these hard to trigger features where we would talk about them and then they'd be very difficult to try and practice. Like another example of that is with stream processing. You could talk all day about streaming joins. They're really, really cool. They have these temporal semantics where you're like, okay, well, if data arrives within the hour, we have the data set up in these caches on memory to be able to be joined correctly. We talk about that, but who's actually tried that? Who's tested that in a variety of ways? Very few people. You could do it with unit tests in like a small setting, but otherwise you kind of just ship it to production and you're like, well, does that work or not? And so, I mentioned a few patterns that I saw. One is the relationally joined data. Another is, I call it sort of like sequential data, where the obvious use case for this one is like if you were modeling retail data and you wanted to do like an abandoned shopping cart use case, the order with which your events arrives matters. So you need like an event that like Hugh went to the website and then he checked out the item, then he put it in his cart, and then he like walked away. And unless you actually have that data, preferably at scale, it is not possible to test all these things that we talk about. There are many more patterns like this. Chaos operations are another one that I see a lot, where like maybe you want to duplicate data on the wire, or you want to delay it from sending out by 100 milliseconds, or you want to discard it on the wire. There's semantics for all these kinds of things in streaming. Again, very few people test these things out before they go to production, and it just felt like we should fix that. Like it would be great if we had a Swiss Army knife to just quickly do these things in a low ceremony way. And that's kind of what informed the the current thinking that I have.
That makes total sense. I think particularly in this sort of the niche of, I feel like niche is our word of the day today. In the niche of building data products for enterprise, I feel like we're kind of in the business sometimes of building race cars, right? And then when you have to go and demonstrate this stuff, I mean, particularly in my work as an advocate, I want to show people all the cool stuff you can do. You kind of need that racetrack, right? Like where you can go and safely show off all of these things. And I think that's one of the reasons why I think shadow traffic, I find it so exciting and so glad to have you on the show, is this idea of like actually having this tooling to showcase the strengths of Kafka and Flink and this ecosystem that is so tightly coupled with these enterprise workloads.
Yeah, it's one of those problems where you look at it. I remember a few people remarked to me when I started, they were like, okay, demo data is cool. Are you really going to make any money off this? And I was like, well, I don't know. I'm going to try it. So I started with like developer advocates, kind of selling to them. What I quickly realized is that salespeople have this problem too, where like, if anybody's listening to this who works in sales engineering, the whole like initial step of trying to sell a very expensive product is to get the technical win. And so you have these prospects who come to you and they're like, well, let's check out this product. Does it do this? And the more quickly you can convince them that yes, it does, and show them with proof, the more quickly you can get on to like doing the deal and getting the money. And that is a problem very much worth buying a product for. And I didn't know that, but like I sort of wandered into that. And that's led to more organic branches into like engineering and all other places. But yeah, I feel like when you find these problems, they're worth looking at, because if you pull on a few threads, you'll be surprised at places where they'll take you. And it's not always the case that they work, but sometimes they do, and they're worth investigation.
One thing I'd love to circle back to, and excuse the non sequitur, we were talking a little bit about joins in there before we got on to this idea of testing. I think one of the really interesting technical challenges, certainly I've run into in the past when doing this kind of testing, is maintaining referential integrity across topics, like doing joins across topics on IDs, ensuring order events reference valid customer IDs. How does shadow traffic's lookup mechanism work under the hood for doing these kinds of things? And what are the performance implications?
Yeah, in broad strokes, like basically what it does is it tries to build a directed acyclic graph of what your data is, and then it works out how to generate data in the right order, like roughly round robin, to say like, well, okay, if I have an order that needs a customer, I must generate a customer first. And then I've spent a lot of time tinkering with the underlying data structures to do this well. So in the beginning, shadow traffic was really slow with this. It didn't really matter, but like, if you do things in the naive way, they won't work very well, especially as you kind of hit larger and larger windows of data. So you need a data structure to support history of the data that you've created that is sort of slidable, where you have a cache of it and it sort of slides out of memory over time because you can't save everything. It needs to support fast operations for put, get, set operations, and a few other things. And I've had to kind of go digging to find the right data structure to do that. And that's part of the secret sauce under the hood. But yeah, I think it's a good example of like one of those problems that sounds easy, where it's like, well, I'll just use like an array for this. And it turns out that doesn't work very well. And you spend more time on it than you think. And yeah, the whole thrust of what I'm trying to do is to have a product that is approachable, that you get really fast, pick it up when you need it, priced well for the use case. Just trying to kind of get all those things in balance.
I really like that point in there about like, oh, I might just use an array for this and it doesn't work. Like I was at PyCon UK a few weeks ago, and there was a great speaker there who was talking about like, oh, maybe consider these other structures rather than a Python array if you want performance or you want these specific use cases. He spoke for an hour. I think he could have spoken all day. Like it's such a specific problem for building performance systems. I feel like doesn't get the attention it perhaps deserves. Is like, yeah, you choosing your structures, particularly in languages like Java, is so important for getting the results that you need.
Yeah, it's almost like you go shopping where you're like, well, I have this problem. It turns out, 5 out of 6 operations work well. What do I do to kind of get 6 out of 6? And then you go into the literature and you try to figure out You apply everything you know about Big O and computer science theory, and you try a bunch of stuff. It's stressful, but it's kind of fun.
I imagine it's very satisfying. Because I can't claim to be a good enough engineer that I run into these problems very often where I'm solving performance issues. But to solve these engineering challenges in your product and be like, oh, I've got such and such a performance increase, or this thing is possible that wasn't before. Like that's got to feel like a huge win, right?
It's cool to know why something works when you nail it, where you're like, okay, I saw that this operation was poor because as n increased, it's doing extra stuff. And then I adopted this other algorithm or data structure that behaves differently, and like bang on, it's not only faster, but I know why it's faster. That's like really the ultimate engineering satisfaction, I think.
Hell yeah. Yeah, I definitely feel that where it's like you're like, oh, I've solved the puzzle and now I know the solution and next time I can use it. Like, yeah, a great feeling. Getting into the kind of the technical architecture of shadow traffic here. So as I understand it, shadow traffic is like compiling generators at runtime, right? So when it finds the generate key. So could you walk us through what's happening when someone defines a generator function in shadow traffic, and what does that compilation process look like?
Yeah, so if anybody hasn't used it, like basically what I ship to my customers is a Docker container, and you give it some JSON that says like this is the data shape that I want to create, and then otherwise like shadow traffic is a black box. You give it to it, and it will connect directly to your backend of choice. Many of my customers that's Kafka, but it also works with things like Postgres, S3. I just add new connections all the time, and then inside like you don't need to worry about how it actually gets the data there. It tries to make intelligent choices for you about how it does that. But you like, again, in broad strokes, how it works is it takes this declarative JSON structure, it turns it into an abstract syntax tree directly, and then it looks for those little call sites where you say, hey, I'd like to generate a number here or a map or an array or something like that. And it uses something very similar to how you would build a programming language. It does it does a bottoms up walk looking for all of those call sites, and then it does top down invocation of those call sites. And when you do it that way, it's actually very fast because you get things like tree shaking for free, because if you have values that will never get invoked, it knows how to skip those branches of the tree. And designing it with those formalisms has actually given it a tremendous amount of performance. It can always go faster, but the fundamentals are really, really good. And people are often surprised when they start it up. And I was with somebody and they were like, oh, I'm going to point it at my Confluent cluster. And it hit their quota like immediately. They're like, well, what happened? And I was like, well, it generated for you like 50,000 messages a second and it nuked your quota. And that was a good surprise in this case. But yeah, that's kind of how it works. It uses a pretty simple model, how you would sort of design any other programming language. But in this case, it's a very like slender one.
Mentioning quotas there, because I know quota is always a source of headaches and controversy and saving you from yourself sometimes. But how do you handle things like rate limiting and back pressure and data distribution when users are building their own templates, feeding them into shadow traffic, and then pointing it at their Confluent or their MSK or their local Kafka cluster?
Yeah, this is another good example where it's sort of like it's a thing taken care of where you don't need to understand it. So obviously, like the back pressure emanates. Let's just take Kafka and Confluent for an example. Like Confluent Cloud implements back pressure and quotas to be able to say, hey, you've produced too much data for your allocation. Please back off. At the client level, you need to handle that and say like, well, okay, I need to like stop generating data quite as fast. There's a whole suite of algorithms and data structures to do rate limiting. Look up things like the token bucket. Data structure and algorithm to be able to like how to handle that. And shadow traffic is built with all that in mind. So every time I add a new connection, I wired up with basically the suite of functionality to handle back off and appropriate throughput on all those connections. And yeah, just another thing where you're like, well, I didn't even have to think about that. It kind of just worked out of the box. And on its own, it's not that hard. You could spend a couple of days figuring it out. But when it's one of 50 things and you don't have to, then it's kind of nice.
That's always huge. We're like, oh, it just works. TM, like it's always such a good feeling. I think a kind of a common thread here is this idea of like the kind of raison d'etre for shadow traffic is that testing with realistic data requires modeling realistic patterns. It requires tooling, to make things easier. You've got bursty traffic, seasonal variations, correlated events. I know we've had some conversations in the past around like simulating ad speed data, as I'm with my real-time with Kafka talk that refuses to die using ad speed data. But what are some of the most challenging patterns that you've worked on replicating synthetically? Like, is it time-based stuff? Is it ordering? Like, what have been the real headaches to get working?
I think anything that involves a very high amount of concurrency and really, really deeply nested data. They're two different problems. I happen to have seen them kind of paired up, and they are like extra painful whenever that happens. And so just to talk about them in turn, like if you have very, very nested data, you're occupying a ton of memory on whatever computer that you're using. And, no matter what you're doing, you need to be sensitive about that and kind of dial in the memory just right. And then, yeah, when you have like a high degree of concurrency, timing matters, parallelism matters about like how many things can you run per machine. Those are always kind of the most tricky in my experience because the demands are pretty high about, if you need to do tens of millions of users or medical patients or sensors or whatever, there needs to be some archetype strategy about how you're going to figure that all out. And every time I manage to figure it out, so my back is against the wall. Can I improve the product enough to do it? But yeah, I find those to always be pretty tricky. And then if I was going to name a third, there's just always some wild card in the business where there's this domain logic that like makes no sense. And but that's just the way it's always done. And there are some escape hatches built into the product to provide relief for those kinds of things. But sometimes that comes up, and that's just the case with any business where the upstream requirements make no sense, and yet you must help anyway.
I've had some interesting experiences in legacy environments, so I definitely feel you on that one. You're like, I don't want this to be the way that it works, but it works, so we're going with that.
Yeah, this is what pays the bill, so we're gonna do it.
Oh, let's do real. So, sort of coming up to sort of the end of our sort of session here, I've got a couple more questions. But one thing that I'd like to touch on is we've spoken a lot about the complexity of this problem today, right? Like, but you're building this as a solo founder after working at some like really large companies in the space. Like, how does this change your approach to technical decisions? Like what engineering trade-offs look different when it's just you building a product like this versus like having a whole team of engineers and the support infrastructure around you?
You could make wrong decisions really fast and kind of get ahead of yourself, I would say. But no, I wanted to do this. When I left Confluent, like I said before, I just like to build things. I wanted to just sort of go to the opposite end of the spectrum. I had seen people succeeding as like this solopreneur thing. It was new to me, and I thought it was cool. And I just wanted to try it because I like to try a little bit of everything. And yeah, I mean, the benefits are that you can move incredibly fast. There's no blockers on decision making. You just have to like kind of get all the facts in front of you, get a calm mind, and then do your best because there's nothing more than that. It's all you have. And yeah, the downside is that if you get nervous or you like panic or something like that, you could ship a feature that it's not compatible with everything else that you've done, or you start to design into an architecture that's like kind of pointless, or you could just waste time refactoring on things that like if you had another person looking over your shoulder, they're like, well, does that really matter? Like, is that important? So maintaining some discipline over goal setting and making sure I know why I'm doing what I'm doing has been pretty important.
Are there any particular like people or types of people that as a solo founder that it's useful for you to like bounce ideas off? Maybe a key customer that you get feedback from, or like peers that you could, vet ideas with when you're like planning the direction of your product?
Yeah, I always try to check in with all my customers when I have a new idea in mind. I try to be basically constantly in communication. And that was one of the things that was really hard in the beginning, where I had like one or two customers, and it was like, well, I have ideas. They're not always available to give me feedback because that's just like, how things go. And it's like very quiet. And there's no magic formula. I just kind of had to muscle through the first year when I had like 5 customers. And then, things have gotten better and better after that. And fortunately, I've sort of grown past that problem, but it's a tricky part in the beginning for sure.
So one final question for you before we wrap up today. For engineers who, maybe they're listening into this conversation today about all of these, different synthetic data generation problems, perhaps for engineers who are struggling with test data generation today, whether they're building their own solutions, God knows I spent a lot of time messing around with Python ETL doing this, or they're evaluating tools like shadow traffic, what technical considerations should they be thinking about? And, where can they go for help?
Yeah, I think check out my LinkedIn because I try to talk about the problems related to this quite a lot in a way that's not so pitchy. Like I don't constantly talk about my product on LinkedIn. I think that's a big thing. And then I would say as far as like technical considerations, take a look at the docs that I've created. I try to talk quite a lot of it, like at a high level, about the considerations that have gone into this stuff, and then from there you can kind of decide about, take my ideas and then reapply them in any way that makes sense. If that's using my product, awesome. If it's not, take my ideas and go run and try them with something else. One of the most satisfying things from building Onyx, like the stream processor I worked on a long time ago, is that the product eventually died. But the ideas, like someone messaged me like a week ago that they're using the abstractions that I created, and they have nothing to do specifically with the product, but they are like a direct product of my thinking, and I find that incredibly cool. So if anything that I've done can kind of influence your designs, whether you use my stuff or not, I'm pretty satisfied with that at the end of the day.
Oh yeah, it's a great feeling, right? You're like, I figured something out, I've shared it, and it's helped someone else achieve a thing. Like, always like a warm, fuzzy feeling, right?
Yeah. What more can you want?
Hell yeah. Well, thank you so much for your insights today, Michael, and for joining us for this conversation. It's been fantastic.
Yeah, thanks for having me, Hugh. I really appreciate it.
Always a pleasure. And thank you to everyone who joined us live for another episode of Get Kafka-Nated. Next time, we'll be doing something a little bit different. I think we were talking in the pre-show about both of us being at Confluent Current in New Orleans, and the show will be there as well. So look forward to some interviews with some of your favorite people from the Kafka community. If you've got topics you'd like us to explore in future episodes, or you want to be a guest on the show, or you have feedback on today's episode, please reach out to me on LinkedIn. Always happy to have conversations about Kafka and about this community. We're always looking for new voices and perspectives, so please do get in touch. Thank you for listening.